I'm Heidi.
I'm Zach.
I'm Haley.
And I'm Jess, and our product is the Jack in the Box.
This is our original product. As you can see, it has raised designs on the side and paint. So this can be bought on Amazon from a company called Schilling. So it functions by, you turn the crank and it makes sound. When the song gets to a certain spot, it releases the latch, which makes it pop.
So the Jack in the Box is composed of approximately 11 components. We grouped these components into 3 sub-assemblies. The first sub-assembly ended up being the side along with the base. This allowed for us to weld the pieces together and make a few design modifications. The second portion was when all of the other music pieces are added, which is what actually gives the Jack in the Box the tune and the crank and all of that stuff. And then finally we put the monkey and the rest of the box and the lid and stuff together to create our final sub-assembly.
The first part that we have is the base of our music piece. This is what it looks like. It's made out of aluminum, and this part was cast, and you can tell by the split line that's right here that was used to break the molds apart. Casting this was a really good idea because of how intricate it is. This would have been very difficult to machine.
So one of the main pieces of the Jack in the Box is actually the drum. As you can see, the drum is made up of a combination of ABS plastic, which would be injection molded, and that's your little end pieces, both here and here. The end piece even has a little lip there, which is actually what releases the latch and opens the top when the tune has completed. Along with these ABS injected plastics, there is also aluminum, and so the aluminum is in the drum, and it's also in little end pieces that sit in the base in order to hold it in place. For the drum, the aluminum is actually processed by cutting sheet metal and poking it, and then wrapping it up and assembling with glue and push fits.
The crank is made using an upspring tool, which creates this 90-90 bend. It first pushes it into a Z shape by crushing it between 2 pieces, and this is an over shape, and it'll then spring back to this 90-90 shape. Then threads are put on right here to allow it to interact with the gears. This part, the knob, is made of ABS plastic, and it is made using injection molding.
The fourth piece that we have is the lid latch, and it looks like this red part here. It was created using injection molding due to its simple design and the ability to create a lot of them in a short amount of time.
So here we see the comb. This piece is used to produce the tune that you hear as the little pushed parts of the drum hit the comb. It produces a note. The comb is manufactured from steel, and the comb is most likely stamped, and that allows for all of the thin lines in between the comb teeth as well as the holes and the overall shape. Extra machining needed is adding little pieces here and there in order to make sure that each tooth is the appropriate tune and note. The screws are actually standardized, so manufacturing processes aren't actually needed.
The spring that holds up the small latch, or pushes up the small latch, is what we call the small spring. It looks like this, and it's just made from an extruded wire that is then put in a machine and coiled until it's in the spring shape.
Another component of this product is the box and the lid. These components are both made out of tin. They were originally cut into strips and squares of the correct size, and then they were pressed into the correct shape. You can see the indents here and on the side of the box. The sides are double layered and holes are added, as you can see on this disassembled one. So this is where the screws and the base will attach to that one. And then they are run through a side seamer. You can see the seam on the side to close the side length. And then when all the components are added to the inside, the top and the bottom are go through a body flanging machine and connected to the sides. To manufacture the monkey, strips of cloth are sewn together.
This is a compression spring with a helical shape. It's made of hardened steel, and it starts out as long pieces of wire, and it's fed into an autocoiler, which makes this in the desired length, shape, number of coils.
Our redesign of the Jack in the Box consists of changing just a few small key parts, the biggest of which is changing how the base of this music piece is attached to the rest of the box. previously it was screwed in, which forced the company to rewrap the box in another layer. That is just another assembly process that isn't needed because of the screws to attach this base. So what we are going to do instead is weld it on, which reduces or takes away that entire need to add another layer. We're also going to get rid of the bumps and surface texture that we showed you before, because that's, again, just another process that doesn't really add anything on top of the paint that's already going to be on there. And lastly, we're going to change the spring constants of the big spring in the middle. So overall, welding is way better than screwing. I mean, screw that, right?
After performing the design for assembly analysis, our group was able to identify different areas that we should focus on improving for our next design. A couple of the areas that we improved were the number of pieces and number of interfaces. We reduced our pieces from 15 to 13 and the number of interfaces from 45 to 39. We also improved the efficiency. On the initial design, there was a theoretical efficiency of 60%, and after our changes, we got our efficiency up to 69.2%. The error and handling parameters were both pretty low at 0.44 each, so we did not change anything about that part for the next process. In our redesign, we did focus on the insertion and secondary operations parameters. By reducing the pieces and processes we needed in our design, we were able to reduce these numbers from 1.89 to 1.78 for insertion, and for secondary options from 2.44 to 2.22.
This is our 3D printed model. This is meant to simulate the base being welded onto the side of the metal box. We chose to do 3D printing because this was the best way to simulate actually welding this on. As you can see, we eliminated the tabs and the need for screws here and here. 3D printing was the most viable option for modeling this type of connection. Because our design change did not change necessarily the shape of this or any of these major components, it still functions the same as the normal box. As you can see, this still functions the same as the original object as a prototype.